Subject motion during an MRI scan can cause substantial corruption in images, reducing diagnostic accuracy. Often, the corruption can only be solved by redoing the entire scan, increasing scan time and cost, and reducing patient comfort. Therefore, motion detection and correction during an MRI scan can be extremely helpful. Motion detection can be achieved by registering time series volumes. When motion has been detected, the scanner can then respond to subject motion in real time by updating the image coordinates to follow the subject's head. The most important step in motion correction is to be able to accurately register time series volumes. These volumes are acquired by a navigator, which is also a scanning mechanism that can come in simultaneously with an MRI scan and acquire fast but low resolution and noisy volumes. During the acquisition, there is a trade-off between time and resolution. We want to acquire these volumes in the shortest possible time interval because movement increases as time interval increase, which means that we need to get the lowest possible resolution to achieve high accuracy. We have a series of 3D volumes with 3 different resolutions: 6.4mm, 8mm, and 10mm. Traditional interpolation methods such as linear and cubic interpolation suffer from uncertainty across volumes when doing registration. Gaussian process has been proposed to reduce such uncertainty using its covariance matrix and thus reduce interpolation error. So we implemented a registration algorithm with Gaussian process on these low-resolution volumes using the squared exponential kernel. To select the optimal parameters for Gaussian process, we used gradient ascent on the maximum likelihood function. We were able to show that Gaussian process can achieve higher interpolation accuracy. In the series of volumes, we have a volume of the initial position and then 3 volumes for 5-degree rotation along each of the 3 axes in 3-dimensional space. For the 3 axes in the volume, 2 of them have heavier noise than the other. Results show that Gaussian process performs very well with the 2 axes that have heavier noise. In particular, we're able to recover the accurate rotation of 5 degrees using just the 8mm resolution in axis 0. In general, for movements along these 2 axes with heavier noise, we can use lower resolution volumes to accurately detect motion, which achieves our goal of reducing time intervals during the scan. However, Gaussian process does not work so well for the volumes that have lower noise due to overfitting, and in this case, linear interpolation suffices.